All right, so I want to know the sum of all whole numbers between 1 and 100. So like 1 plus 2 plus 3 plus 4 plus 5, all the way up to 100. There are some clever ways to go around this and to figure this out. You could use that same formula that we did for before, so you could start at 1, go up to 100, and then just keep adding them. That should be n. However, that seems a bit redundant, so I want you guys to talk to each other and see how could you go about figuring out an easier way to add up all the numbers between 1 and 100. So turn and talk to each other. There's actually a lot of different ways to go about doing this. I should have. All right, so Christian's way is one way, Finn's way is a good way, Maddie's way is a good way. Each of them work. So, all right, so I have 1 plus 2 plus 3 all the way up, and I'll go to 97 plus 98. All right. So I like what Maddie's saying. She's like, okay, if I do 99 plus 1, that gets me 100. 98 plus 2, that'll get me 100. 97 plus 3, that'll get me 100. Christian is saying, okay, if I do 1 plus 100, I'll get 101. All right. So then you said you multiplied by 50.
By 101.
Why did you multiply by 50?
Because for the two groups that you made, it ends at 50 and it ends at 101.
So yeah, so I can do 1 plus 100, that'll get me 101. And I can continue doing this until I meet in the center, right? So once I get to, I'll get to 50 and 51 in the middle. And that'll be my last pair that gets me 5. That'll get me 101. So this is one pair, second pair, third pair, fourth pair, and then I'll have 50 pairs of those. So if I do that, I'll get 5,050. Is that what you got, Finn, when you put it in your calculator?
No, it gives you like the whole. Oh yeah, I got that in the calculator, but like, for the actual formula, it gives you all the boxes and you just fill out whatever you need.
Yeah, cool. So that's another way that I'm going to show you towards the end of how to plug it in your calculator. And then you could still do it this way with adding 99 and 1. You're just going to have one less pair, and you have to make sure that you have your 100 at the end, but that's also another way to do it. Okay, so after discussing that, I want you guys to figure out the numbers between 1 and 60. So you could use the same method we did as before, but now I want to know till it gets to 60. All right, so if I wanted to set it up like I did before, so before I had 101 times 50. So if I wanted to set it up like that, how could I do that with the numbers between 1 and 60? Yeah.
61 times 30.
Awesome, so we'll have 61 times 30. And that gets us
1,830.
Thank you. 1,830. All right, yeah, so same thing. We're adding 61 plus 1, 2 plus 59, that's going to keep getting us 61, and now we'll have 30 pairs of those. So I'm doing this pattern for a reason. So think now instead of between 1 and 60, say I wanted it between 1, I'll say n, if I want to put a variable in there. Because that way I can just plug any number I need to in there and I'll be good to go. I'll have a general thing for the rest of it. So based off of this, we had 101 plus 50 for between 1 and 100. This was for 60. So I want you guys to discuss with each other, come up with a general formula, give you guys like a minute to do that. What formula could I use to try and come up with? If I just want the numbers between 1 and 10. All right, Robert, you had your hand up. What were you thinking?
1 plus n in parentheses and then times n divided by 2.
So explain how you got that.
The 1 plus n, because that's less number, and it needs to be in parentheses, or else the division would, like, it will be out of sorts. And then it's like the midpoint of the whole number, last number, so you divide it by 2.
Awesome. So this is actually, you guys just figured out with that. So this formula here is the same as this one. So I know it looks a little different, trust me, it's the same. So we have our first term, right? So our first term for all of these was 1. So that's where we have our 1 here. And then we have our last term, which in each time we were adding by 1. So our a sub n was equal to n because we were just increasing by 1 each time. And then we have by the number of terms divided by 2. So it's the same formula that Robert